Good morning, students. Good morning, all of you. This is Yasmin Sheikh. I welcome you to Bruhan Mumbai Municipal Corporation's statewide online lectures. This is Science 2 subject for Standard 9th. All of you sit properly and listen carefully. Try to understand. I'll be asking you the questions at the end of the period. Okay, so today we are going to start with the 18th chapter of Science 2, that is observing so from the chapter itself you can understand we are going to do an interesting chapter. Everyone likes to know what is there in the sky, isn't it? All of what sky at night we like to see moon, stars, and interested in this space, right? So today to do an interesting chapter. In this chapter we are talking about forms of light, telescopes and telescopes, telescopes is and also to set out ISRO, that is Indian Space Organization. All sky information. Hello. Okay, I'm sorry, there was a network issue. So we are going to do chapter 18, observing space telescopes. So in this chapter, we are going to study different forms of light, telescopes and the types of telescopes. And can you recall what is the difference between sky and space? Can you look at the sky and space? See this picture we see every day that we call it as sky. So let's see what actually is the definition of the sky. the sky is the region in which scattered Earth's atmosphere, making it visible from the surface of the planet. Space everything. So the sky is the region which you around you, the atmosphere which we see around us, the light is scattered. So sky is nothing but the region in which the sunlight is scattered in the Earth's atmosphere, making it possible from the surface of the planet, while space is everything beyond that. The sky also includes all the objects as far as we can see outside of the Earth, right? So whatever we can see in the visible light, so that part we call it from our planet, that part we call it as sky. But there is much more sky, or there is much of the space of that. The sky after that, that we call it as space. And what is space? So in astronomy and cosmology, space is the vast three-dimensional region that begins where the Earth atmosphere ends. Space is usually thought to begin at the lowest altitude at which satellites can maintain orbits for a reasonable time without falling into the atmosphere. Right? So, space is beyond the sky, wherever we think that whatever we cannot see after the sky, that is space. When space is really dark in color, because there is deficiency of oxygen. What is meant by space observation and why is it important? Right? Space observation, in simple terms, we call it as space watching or sky watching. Right? So, why do we think we like sky watching? Isn't it? We like to see in the sky, and it is useful also. So, from early days, man has been curious about sun as well as the moon and stars seen in the night sky. Using his boundless imagination, he tried to understand the sky as observed by the naked eyes. He noticed that the position of the stars changed with time and had something to do with the occurrences of the season. So he tried to understand seasons by watching the sky, right? You must have seen in the movies also, in the olden days, where they look at the sky and they try to understand whether it is going to rain in few days or not, whether it is going to be no rainfall this year, or whether it is going to be very heavy rainfall this year. So that way uh, they used to imagine by watching at the sky, as the knowledge of the cycle of the season was necessary for agriculture, right? So in the olden days, so everything was dependent on the agriculture. Most of the people used to do agriculture, and so the sky watching was very, very useful for them. Sky watching began to prove useful for the people. The position of the constellations, that means the position of the different group of stars, was also useful to seagoers for navigation. You must have also heard that watching at the sky in olden periods, the people used to do the navigation. Navigation means moving in the sea or moving in the ocean with the help of uh, boat or ship, isn't it? So man began to make determined efforts to find answers to questions which arose out of his sky watching. But he did not have any equipment to get a closer view of the stars and the planets in the sky. So he was not having any equipment to see, have a closer look that what is there in the sky. So he used to only watch with the help of the naked eye and try to understand the behavior of the sky or the behavior of the celestial bodies which are there in the sky and the effect of them on the earth. So those were, now let us see the benefits of the space research in today's world, right? So improving health care, experiments performed in space help us understand health problems on the earth, right? So different health problems we can solve by finding out or by observing the sky. Protecting our planet and our environment. Satellites provide data on climate change, major pollution, and help protect our planet. Right? Nowadays, because of the improvement and much progress in the technology, satellites have been sent in the space. We all know, isn't it? There are many satellites which are working in the space. So, what does the satellites do? These satellites provides data on the climate change. So, whatever climate change is going to happen, whether it is going to be you must have seen the example. High alert is declared by our government, by our municipal corporations whenever there is going to be high tide, etc. So that's we come to know because of the satellite which is placed in the sky. So the climate change or the weather change, then pollution, measure of pollution, whether there is high pollution in some cities. So that is also noted by the satellites which are sent in the sky. So these satellites, they hang in the sky region, right? And after that, where the gravitational force is very weak, or where the gravitational force ends, that area we call it as space. So sky is nothing but so improving our day-to-day lives. Space technologies improves products we use every day, weather forecast and communications worldwide, right? So whatever we are connected with Google, we are connected with internet, we are connected with mobile phones, we can call each other around around any place in the world. So that is because of the space research, that is because of the satellites we are sending in the space. Enhancing safety on Earth. Satellites data can be used to predict natural disasters and to support emergency efforts. Right? So, the satellites or the telescopes which we have placed in the sky or in the space, they help us to uh, predict the natural disasters. Example, it can be like examples. It can be like tsunami or the natural disasters like earthquake. So it can be predicted. So making scientific discoveries, scientific breakthroughs are challenging our assumptions and pushing our boundaries by exploring the unknown, right? So we are trying to explore the unknown things in the space, and so that is also helping in the scientific discoveries. Okay, so as in the previous days, there were no equipment to get a closer view. After that, so there was a scientist, there were some people who tried to find out to see the far objects. So the object which we use to see or to watch the sky, that is called as telescope. Let us see what is telescope. An optical instrument designed to make distant objects appear nearer, containing an arrangement of lenses. So we can see the distant objects closer because we are using lenses in that, or of curved mirrors and lenses by which rays of the light is collected and focused and the resulting image is magnified, right? So that is called as telescope. So this is how the present telescope looks like, but the this was not the case, or this was not the structure of the telescope when it was discovered for the first time. So in 1608, almost 400 years ago, spectacle maker, you know, spectacle maker, the one who makes the specs. So that person was there. Spectacle maker and researcher Hans Lippershey, his name was Hans Lippershey. He discovered that seeing through two lenses kept one behind the other seems to bring the objects closer to us, right? If he found that if we keep two lenses one behind the other, so the distant objects can be seen closer. He was the first person to notice that, and he thus made the first telescope. So he was the first person to make the first telescope. But this person, Galileo Galilei, this was the first person to use that telescope to observe the space. So Galileo made a telescope in 1609 after 1 year and used it for space observation. He realized that there are many more stars than what could be seen with the naked eyes. So when he has observed the sky with the help of the telescope, so he has seen that whatever stars we can see with our eyes, so there are many more stars when he has seen with the help of his telescope. Using his telescope, he also discovered the moons of the Jupiter, right? So 400 years ago, he has also seen the moon of the Jupiter. You must be knowing, this is a general knowledge, that the Jupiter has 16 moons, right? As we can see one moon from our Earth, we can see only one moon. But if you will stand in the land of Jupiter, you can see 16 moons. So there are 16 satellites to the Jupiter. So he has seen the moon of the Jupiter from with the help of his telescope, yeah, 400 years ago. He has also seen the black spots on the of the sun. So nowadays we know that there is black holes of the sun. We have studied, isn't it? So at that time he has also seen those black holes or the black spots of the sun. So you can see the picture. This is the person, Galileo Galilei, and this is the telescope made by him. So today, 400 years after Galileo's use of the telescope, tremendous progress has been made in telescope technology and in the space science and technology on the whole. This great leap in technology has helped to construct for us an astounding picture of our universe. Space science and technology are not only important for research purposes but also to help us with many of the comforts and facilities we enjoy in our everyday life. So we are enjoying many comforts and facilities, isn't it? So we are using internet. We get the answer of whatever question we have in our mind. We uh, we are access to internet, isn't it? So this is because only of the space science technology. isn't it? Then we can watch TV, we can hear to radios, we are connected to each other with the help of telephone, right? We can talk to any person on the in the whole world, wherever he is in any part of the earth. So we can talk to him. So we are communicated, we are interconnected to each other, we are having all the facilities. So that is because of the improvement or progress in the space science technology. Also, we are informed well beforehand of any natural calamity or the weather change, isn't it? So, a telescope is used to observe space, but will one telescope be sufficient for us to observe the space completely? Now, the space is so large, still, no scientists have found out the end of the space. Still, we don't know where the space is ending. Still, we think that there is no end to the space is endless, right? So, is only one telescope sufficient to observe the whole space completely? No. So, why do we need different telescopes for this purpose? Are telescopes installed even in the space? So, in this chapter, we are going to study the science behind many such questions. So, before we try to understand the different types of telescopes and the telescopes which are placed in the sky, first we should know simple things. First, we should know the different forms of light which are there, right? What is light actually? So, light is an electromagnetic wave. Light is nothing but the electromagnetic wave. Every wave has a characteristic wavelength. We have seen in previous classes what is wavelength. I'll explain you again. That every wave has a characteristic wavelength. So our eyes can see only that light which has wavelength between 400 nanometers to 800 nanometers. Such light is called visible radiation, right? So you can see here. So we all know that the light travels in the form of a wave. Okay, it travels in the form of a wave, but it travels in a straight line. Are you following what I'm trying to say? Always, all the kinds of radiations or all the kinds of light, they travel in the form of a wave, right? So when you form a wave, there is crust and the trough. The mountain which is above the line, which you can see, the mountain structure, that we call it as crust, and the below structure that we call it as trough, right? So the distance between two crusts is called as wavelength, right? So this wavelength can be very small, this wavelength can be medium, this wavelength can be large, right? So the distance between two crusts or two troughs is called as wavelength, right? If the waves are very close to each other, the wavelength is less. If the waves are far, then the wavelength is little bit more. If the waves are very far, then the wavelength is more large, right? So what light we can see? So the radiations which have the wavelength between 400 nanometers to 800 nanometers, that light we can see. That is called as visible radiation. However, there are electromagnetic waves of wavelength other than the visible ones, most of which we cannot see as our eyes are not sensitive to them. So there are other types of light also, there are other types of radiations also which we cannot see with our naked eye, right? Those are called as, those are not visible radiations, right? So we can see, or whatever we are seeing, that is only the visible radiation. So what examples can you see, give me of the visible radiation? So the radiations of the sun, which with we are getting the light. So the radiations of the sun, the light which we can see, or the radiations of the sun or the light of the sun which we can see, those are visible radiations. That means the wavelength of those radiations are 400 nanometer to 800 nanometer. Also, the light of the tube light. Now at night when there is no light, right, we can see with the help of the tube light. So the also the lights or the radiations which are coming from the tube light, that is also between 400 nanometer to 800 nanometer. That is why we can see in that light. So that is also a visible radiation. Then bulb, tube light, these are all visible radiations, but there are many radiations which we cannot see with our naked eye. Now, let us try to understand. See, 1 nanometer is equal to 10 raised to minus 9 meters. Can you see the wavelength? It is so small. The distance of 1 nanometer is 10 raised to minus 9 meter, while 1 picometer is 10 raised to minus 12 meters. Now, let us see the different types of radiations and the wavelength. So, you can see here the radio waves, they have the wavelength longer than about 20 centimeters. Can you imagine? That means the waves of the radio waves, they are very big. They have the wavelength, distance of the wavelength of 20 centimeter. 20 centimeter is, we have one small scale of 10 centimeters. So two scales, if you keep that much distance, 20 centimeter distance it has in the one wave of the radio waves. So the wavelength is very large. While microwaves, they have the wavelength from 0.3 millimeters to 20 centimeter. So these are also larger waves. Then infrared waves, they are 800 nanometers to 0.3 millimeters. Then visible light rays, they are 400 nanometers to 800 nanometers. Ultraviolet rays, they are from 300 picometer to 400 nanometer. Then X-rays are from 3 picometer to 300 picometer, and the gamma rays are shorter than 3 picometer. That means very close waves. They are very near to each other. They travel with a very less wavelength, right? So these are the different types of lights or waves which we can see. Have you followed? Radio waves, microwaves, infrared waves, visible light rays, ultraviolet rays, X-rays, and gamma rays. Now you can see here types of electromagnetic radiations. See how we are making use of this. So you can see here radio waves, microwaves, infrared waves. These we cannot see with our eyes. We can only see the visible light. Only these rays we can see, the visible light. The ultraviolet, X-rays, gamma rays, these are not visible to our eyes. Okay, let us see where these electromagnetic radiations are used. So the radio waves are used to broadcast radio and television. Then microwaves, these are used in cooking, radar, telephone, and other signals. So our telephones are using microwaves. The microwaves which we oven which we use at our house in our houses, those use microwaves. Then infrared waves, these transmits heat from the sun. Transmits heat from sun, fires and radiations, right? Then visible light, this we know that we can see this light of the sun, that is visible light. We are using that visible light also in the solar heater and the solar cooker. Then ultraviolet rays, these are absorbed by the skin, used in the fluorescent tubes also. We cannot see ultraviolet rays, but they are penetrating our skin, they are present. Then X-rays, all of you know X-ray, it is used to view inside of the body. That means it is used to, these X-rays are used to see the bones, so, and the other objects. Then gamma rays, it is used in medicines for killing cancer cells, right? So gamma rays we are using in the field of medicine or in the field of medical for killing the cancerous cells, right? So we are using such different types of radiations. So of all the above types, our eyes are only capable of seeing the visible radiation. Thus, we use the visible radiation telescopes, that is optical telescopes. So the telescopes which use the visible kind of radiations, those are called as optical telescopes. Also, we use other different types of telescopes also. We use the Cassegrain telescopes, right? We use refracting kind of telescopes, so that we are going to study in the next period. So, however, many heavenly bodies emit radiations other than the visible light. Thus, we need different types of telescopes also, isn't it? So, many different types of radiations are emitted in the space. So, we cannot use only optical telescopes. We need to have different types of telescopes also. So thus we need different types of telescopes like X-ray, gamma ray, and radio telescope to receive such radiations and to study their sources. Okay, so that we are going to study in the next period. So I hope you have followed till here. So today we have seen what is sky, what is space. Then we have also seen what is a sky watching and why it is important. We got to know about the Galileo and his telescope. We have seen different types of light. We have seen what is wavelength, what is visible waves, and what are invisible waves, right? So we will study in details about different types of telescopes in the next period. So I'll stop here. Thank you.
Thank you so much, Jasmine teacher.